Dear students, good morning. Let us continue the solution for the problem, an example problem that is being taken in the last session. Okay, so we have solved only the external support reactions. Now we will go for internal unknowns. Like, see, this is the problem taken in the last session. So, span AB, cable span AB, 10 meters, and assumed a load of 10 kilonewton at 2 meters from left. Okay, and it is YC is assumed as 0.5. YC is a given data. So using the equilibrium equations, and equilibrium equations are not sufficient. That's why we have used a condition also. This is the condition that moment at C is equal to 0, right? Okay. Now, out of 6 unknowns, total 7. Out of 7, 1 is a given data. So there are only 6 left, 6 unknowns left. Out of 6, you have found HA, HB, VA, VB. There are 4 unknowns you found. There are only 2 left. So what are those 2? TAC, tension in the cable portion AC, TBC. Only 2. So to find these 2 unknowns, you have many ways. Okay. So you can take the help of the engineering mechanics knowledge, what you have studied, the knowledge of collinear forces that you have studied from force systems in your engineering mechanics, or else the equilibrium equations at a joint. Okay, you can draw free body diagram for each joint and solve this, right? Likewise, you have many ways to do. We will see each one of them. Right. First, let us see how to solve this by the technique of collinear forces. Okay. Right. Let us see this at A. I'm drawing the forces at A. This is reference line vertical, reference line horizontal. Okay. Right. Now HA. So just HA, VA. HA is H now. VA. So TAC is like this. This is TAC. This is the situation at joint A. So there are 3 forces acting on joint A. So this is like free body diagram of joint A, right? There are 3 forces which are acting at A. So you can make 2 forces into 1 by the way of resultant in the form of resultant, because I know H value. How much it is? 32 kilonewtons. I know VA value. What is VA value? 8 kilonewtons. Okay, so in fact, the length of the arrow, so if this is 8, this is 32, this should be 4 times. 8 fours 32, right? So this is, right. So this will be the resultant. Right. How do you calculate the resultant value? It is just by, so this is what I mean, a resultant of V and H. What is resultant of V and H? The square root of H square plus VA square. So it is square root of 32 square plus 8 square. How much? So let me calculate. Square root of 32 square plus 8 square. 32.98. 32.985. 32.985 kilonewton. Okay. So this is the resultant value. So now how many forces are acting at A? There are only two forces. A is in equilibrium. So if A is in equilibrium, if any body is in equilibrium, if there are only two forces are acting, how those two forces should be? Those two forces should be equal in value, opposite in nature, and shall act along the same line of action. That is what is called collinear system. Okay, collinear, same line, right? So that's why you know R value. So TAC should also be the same. Okay, so this is equal to TAC. So this is one way of finding TAC value. Then what about the other way of finding the TAC value? Okay, let us see that also. Okay, so this now let us remove this. Let's see that how you solve without this concept of collinear force system. Okay, right. Now you say there is this is the angle theta of TAC. So I call this as theta AC. I can calculate theta AC value, this angle. Reason I know YC value and I know this distance. So from this triangle, I can get that theta AC value. So what is that theta AC value? Theta AC is equal to tan inverse tan theta is opposite side divided by adjacent side, means YC by 2 meters. tan theta. So we want theta. So tan inverse of opposite side 0.5, adjacent side 2 meters. So what is the value of tan inverse? You also do the same along with me. 0.5 divided by 2. 14.04 degree. Got it? So 14.04 degree. Okay. 0.36. I have rounded off to 2 decimal places. Right. Now you apply equilibrium equations because A is in equilibrium. Particle A is in equilibrium. So sigma Fx 0. What do you write? Horizontal forces. So TAC has got two components. One is horizontal and another is vertical components. Write the components. So this will become TAC cos theta. This will become TAC sin theta. Got it? So two components. So horizontal forces, how they are? 32 and TAC cos theta. They are opposite, right? So 32 minus 32. If you assume the left hand side acting forces as negative, plus TAC cos theta is equal to 0. So what is TAC cos theta? TAC cos theta is equal to 32. Similarly, if you apply sigma of y0, what do you have? Upward force 8, downward force Ta sin theta, TAC sin theta. So upward, if you take positive, so 8 minus TAC sin theta is equal to 0. Got it? So now what is TAC sin theta? Is equal to 8. So from these two, you should find TAC. What do you want is only TAC, right? So what you do? So you eliminate theta. How do you eliminate theta? Square the both. So you get cos square theta. You square this one also, sin square theta. So add these two. Cos square theta plus sin square theta is equal to 1. So what happens? Theta will go into that mathematical expression. Theta will be eliminated. And what do you have? Only TAC. That's what it is. So T square on both sides, right? So TAC square cos square theta. So I'm taking both as common. TAC is in both the terms. So cos square theta plus second term also left hand sides TAC square sin square theta. So I'm doing it as sin square theta is equal to right hand side 32 square plus 8 square. Left hand side square and add, right hand side square and add. So this become 1. So what do you have on left hand side? TAC square. Right hand side 32 square plus 8 square. So what do you want for TAC? If you want, take root on both sides. So what you are getting? Same thing here. Okay. So instead of doing this concept, you can go with this concept also. Similarly, on the other hand side, if you do it, you will get TBC value. So I straight away write TBC value with the concept of what? Collinear system. So what do you have? VB square root of h square plus VB square you should write. So what is h 32 square? What is VB 2? So it is 2 square. So what you get with this? So let me do it. Square root of 32 square plus 2 square. 32.06 kilonewton. 32.06 kilonewton. Okay. So this is how you are going to solve this problem completely. Now you see vertical forces are 8 and 2. 8 towards the nearer support, heavy load, heavy reaction towards the support, nearer support. H value is too high, 32. And you see TAC means the joint which has got nearer to the load is having very high tensile force value in the cable, whereas the other end is only having 32. Here 32.985, here it is 32.06. So where the maximum force is developed in portion AC wire. So if at all, if the cable is weak, where it will fail? Between A and C. Okay, BC will not fail. First AC will fail, right? So this is how the complete solution for the assumed problem. What is that? We have just for as an example and to deal with a simple case, not to go for too many unknowns in the initial stage of the problem itself. So I have just taken a very minimum case of the unknowns, the least possible case of the problem. Okay, so what happens if you have one more load, for example? This will become three segments. Okay, support same, and how many unknowns increased? 7 plus 2 force means one. There are earlier two tensile forces. Now it is 3. So one increased. Plus one geometry increased. So how many unknowns? Total 9. Okay. So if there are 2 point loads, you will have 9 unknowns. If you have 1 point load, you will have 7 unknowns. Like that. So how many equations you are able to write? A, B, C, D. Another joint. So 4 to 8. 8 equilibrium equations are available. So one unknown is required. One additional equation is required. That already you either YC or YD. One of the values should be given, or any other relation in terms of geometry should be given. That plus one additional equation is required. Otherwise, you can't solve the problem. Okay. Right. So practice the solution with this example, and also the earlier example that we have solved. Let me show you that also. So earlier we have taken this example for solving. So practice this one. Okay. We have solved this completely, right? And practice the example, the simplest one that I have told you, so that you will get no, command over this cables with point loads. Okay, right. So we will come back to the other session with different, still some more problems. You see that. Okay, so let us try solve them also. Okay, right. Yeah. Thank you.